Tonight my talk will be an update of the previous talk I gave to Tesla Society 2 years ago. It will be mass energy creation from the laboratory up to including the Earth, the planets, the stars, the galaxies, and the clusters of galaxies. In this sense, and in the conclusions, coincides very much with Paul Laviolette's previous talk. It differs, though, in the details. The reason is that Paul's approach is rather statistical. My approach is rather from a specific point of view, and that is the energy generated in every spark, almost in every spark, for which might vary from 5% in excess up to 2,000% excess energy in a spark, provided the geometry and other factors involved are appropriately chosen. The essence of my talk will be simplicity. Though I'm a professor of mathematics, I don't suffer for any complex of inferiority or any complex of superiority in mathematics, so I'm not going to demonstrate to you my knowledge in mathematics. I will keep it as simple as possible. It was a while ago. There's the extension should be. Okay, can you unplug that one? We don't need that. So the mass energy generation phenomenon from laboratory to clusters of galaxies and the mass energy production. Basically, we shall assume that matter is electrical, and we shall make a drastic distinction between closed circuits in electrodynamics versus non-closed circuits in electrodynamics. Basically, I would like to be brief, and this is something that I have mentioned in my previous lecture. There are two basic flaws in electrodynamics. The first is that opposites always attract. This is something we learned in school, and this is not the case. It's only in a very, very special case, and that concerns only electrostatics. For example, if we have opposite charges, they attract, and if they are free, they annihilate each other, so the end effect is nothing and energy is released. However, the most dominated force in nature is between similar charges, that is the gravitational force, and all the magnetic forces. It's only the convention we assign to north and south pole that makes opposite poles to attract. But as a matter of fact, in reality, if we have two similar loops with two similar currents, they do attract. This is what is in essence. If we have a loop and another loop which are identical, in orientation are identical, they do attract. If we have two parallel currents, they do attract. That's the Laplace force between the currents. And this is the forces that dominate chemistry, biology, and almost everything in the universe. It's only the exception of the opposite attracting each other. This is something that mankind has not paid attention, because attraction of similar things is much different than the attraction of opposite. For example, if two similar things are attracted and are free, they are going to fall on each other and are going to build up. Whatever they have a field, the field is going to build up. They are going to produce the same energy as opposite will be attracted, but at the end, there will be nothing will be consumed. It's essentially different. For example, if we have a planet and more mass is attracted to it, the gravitational field of the planet increases, does not annihilate. If we have a current stream like this one here, And if the currents are allowed to approach each other, their magnetic field, which is known, will increase, will not annihilate. So there is a case, intuitively speaking, that produces energy without consumption. And we shall see that this is the case actually. Now the second flaw in physics concerns the concept of magnetic field. In essence, what is a magnetic field? Is a concept to describe the forces between currents. It's a mathematical concept. Pardon? Right. It's not audible. I'm saying in the magnetic field is a mathematical concept to describe the forces between moving charges or between the electrical currents. The essence is the correct description of those forces. Now, experimentally has been proved that the magnetic field does not describe the correct forces in certain cases which involve open circuits. And it always describes the correct forces involved when the circuits are closed. In electrical engineering today, almost 99% we have to do with closed circuits. So we don't have to bother using the magnetic field whether we are going to reach a correct conclusion or not. Always we reach a correct conclusion. However, there are cases which are not closed circuits. It was a hidden assumption in Maxwellian electromagnetism that all circuits, closed or non-closed circuits, physical non-closed circuits, are equivalent to closed circuits. Like the one that Paul Laviolette has shown you. Say we have a circuit which is interrupted with a capacitor, like that. This is a physical open circuit. Assume we have an alternating current going through it. Numerically, the Maxwell predicts a displacement current numerically equal to the real current there. However, physically, it's questionable whether the displacement current, though having the same numerical value as the real current, are really equivalent. If you believe into an ether, as Maxwell did, there is no problem about it. Because if this circuit is inside a magnetic field, which is caused by another coil, say, then forces will be applied to the wire here. Also, forces will be applied to the ether, and vice versa. This circuit here will apply forces on the source, which will obey probably the Newton's law of action and reaction. And this is something to expect when you have something between the plates. If you assume there is nothing between the plates, then this is a puzzle. This is a puzzle. The circuit, this circuit, and the circuit which is physically closed will not receive the same forces. Total force will be a difference between the two. So as far as forces are concerned, displacement current is not obviously equivalent to a physical current. Now, experiments like the one with the open antenna, that is an experiment of this type, or the pi frame experiments, this experiment has been done 3 times using various antennas from microwaves to short waves and long waves. It is an antenna at this shape, an S shape, and the standing wave pattern is established here so that the maximum current there is around the corners. Now, if you estimate the forces between the current here and the current here, you find a force like that and a force like that, and similarly a force there and a force there. Now, in a standing wave current, the currents will reverse, but 2 reversals will not alter the direction of the forces. So always you expect the pattern of the forces on the standing wave antenna to be the way that are shown there. So you expect the antenna to rotate as it is sketched now this way, I have spent over 8 years experimenting with forces on antennas and pi frames and so on. And I had calculated beyond any doubt that this antenna would rotate. As a matter of fact, I had the sensitivity over 1,000 times, and the antenna was not rotating. This is actually a variation of my pi frame experiment. Just if you reverse this side here, you get a pi frame, which this makes a connection with mercury traps, and when it's connected there, the pi frame does move forward. But now the explanation is not because of these forces here, and this force which will be reversed there, but because of the longitudinal forces between this and that section. And actually, if you increase the current, you see the mercury dripping off the traps. Many times I have split it off, the mercury from the reaction back there. Classical physics, after I had published this in 83, 85, they developed the technology which is called railguns used in Star Wars. They assume that the force is coming from the field, the E cross and is radiated backwards. And the advice not people to stand back here because they might be killed from this radiated energy. However, if we have a momentum gained in the bridge and momentum given into the field gains also energy. The gain in the energy of the field was in excess of 200,000 times of the energy supplied in the bridge. It was absolutely a paradox there. It has been published in 83. No counter reactions about it. And it showed two things: that the Poynting vector is not working. The Poynting vector was violating conservation of energy. However, no excess energy was observed. So there was no usefulness about it whatsoever. So I think those two experiments throw out of the window relativity. Now the antenna experiment was sent to Nature. Nature sent it back to me as usually. When they see my name, they send it back, say, Professor Pappas, we don't want you to waste your time. I mean, you better send it somewhere else. And it's going to be published eventually. After it was being accepted for 12 months, having a letter of acceptance was returned back to me. Actually, an answer for your question, there is a filtering in the establishment. If you submit something that is in favor of special relativity, is welcomed. If it is against relativity, it's been censored. This is the reason you don't see so much publications against relativity. It's not an equal term. If you try to publish something against relativity, you have no chances. So I don't want to extend that to go to Hall and Keating experiment. That it's another experiment that has thrown relativity out of the window. However, NASA never repeated that experiment. The Russians never repeated that experiment. It was a very easy experiment to be repeated with modern technology. But since then, I have never heard anything. The experiment has been constantly suppressed. Okay, so the electrodynamics of closed circuits, I make a very sharp distinction between electrodynamics of closed circuits and electrodynamics of non-closed circuits. And I will make a brief reference to a speaker in bioelectronics this morning who said he was using two coils with opposite currents balancing each other. I consider this case to be a case of a non-closed circuit, because technically it's impossible to balance, to cancel its current in two coils. There will be an imperfection, so actually a fraction of a turn will be left out. Whatever you can, as much as you try, a fraction of a turn will be unbalanced. between the two coils. So actually you have to dial with a non-closed circuit. And this obeys different electrodynamics, which we shall see in a minute, producing longitudinal waves, which now people are calling it scalar waves. And personally, I don't understand what do they mean about scalar waves. The moment that the B field is zero, A field is zero, everything is zero, still they have scalar waves. Okay, the right law to describe this situation is the law which was called the cardinal law of electrodynamics by Maxwell himself. He respected so much that law that he was saying that will always remain the cardinal law of electrodynamics. However, very quickly we forgot this law, and we replaced this law by the modern form of Lorentz. This law was invented almost 200 years ago by Ampere, and actually the name of Ampere, that's another peculiar historical strange thing. They call the Ampere's law another law, which is the circulation law. Or sometimes they call the Biot-Savart law, which has nothing to do with Ampere. The Ampere law is not anymore listed in the literature, has this form, and also always preserve action and reaction, and has some nice properties. Now this law is being replaced by the Biot-Savart law, or the combined law of Lorentz, which is used in modern relativity. The characteristic of this law is that the force is always perpendicular to the motion of the charges, or perpendicular to the current. The characteristic of this law is always, the force is always along the line joining the two currents. If the one is there and the other is there, the line joining them. So the force is always along the line joining the two currents, and in this way they are equal and opposite. If we reverse the indices there, the force reverses sign, so it preserves nicely the action and reaction law. And the very strange thing about it, or the game that nature has played to mankind, is that those two laws are equivalent when they are integrated around closed circuits. It's a very peculiar coincidence. It's a mathematical coincidence. They are equivalent, so that the integrated Lorentz law behaves just as the Ampere law. So the integrated Lorentz law preserves action and reaction. For example, in the literature, there is no complete proof about this action and reaction preserving when the law is integrated. Always, say, the Jackson's book prove that the magnitude are equal, but never they prove that they are on the same axis. So don't have a very high esteem for the 20th century mathematics and rigor. Actually, I couldn't find any proof about it. So the peculiar thing is that those two laws are equivalent when they are integrated around closed circuits. And there is another also detail which was not known and came to be known to me quite recently, and it's been published in Physics Essays also in last March. The equivalence ceases even if the circuit is closed if the density of the current charges changes. That is, if we have a closed circuit but somewhere the density of the carriers changes, that is, we have a spark gap somewhere there in the closed circuit, then the two laws are not equivalent. Or if we have along this closed circuit we have just another material with a different mobility where the density changes again, and that is the case in semiconductor devices, which are deliberately made out of different materials with the PN regions and so on. Then the two laws are no longer equivalent. Now, when the circuit is closed, the Ampere law has a very special form. First of all, Between two currents, if we have a coaxial current, there's a very characteristic which is not found in the Lorentz law. If we have a coaxial current like this, then the currents repel each other. They do repel. However, if they are in a closed circuit, if the circuit is closed, this section will repel that. So this will be repelled that way, and from here this will be repelled that way. So the longitudinal forces will cancel out. So as a matter of fact, in a closed circuit with uniform mobility, there is nothing special about the cardinal law. The longitudinal forces cancel out, and the two laws become equivalent. And in every section, in a closed circuit, the forces are perpendicular, as we know from the Lorentz law or from the Biot-Savart law. However, if in the closed circuit, in a section, somewhere there is a change of mobility, say like having the current goes through a spark gap, then we have strong longitudinal forces. The proof of this you can see in the physics essays in March, this March. Okay. So we have in mind that something special we should expect in sparks. Now let's make a brief analysis what happens in arcs. If we take this law and we expand it down, we come to this form. We take the Can you see this? Okay, we take the Lorentz law and we expand it. We find out that is this factor here times that. Now the characteristic of this is always positive, which means that whatever are the two moving charges involved, they will never repel. If there are two identical charges moving according to this law, they will never attract each other. They will always repel. Two similar will always repel. Remember what I said at the beginning. Whatever is the situation. And this is in vacuum, not in conductors, because sometimes the current is neutral in a conductor. I'm talking about charges moving in vacuum or in an ionized gas. This law predicts clearly that there will be no pinch effect in an ionized gas. There will be no, how did you call it, George, Casimir effect? Casimir pinch. I don't know how Casimir reached that point, but classical electrodynamics clearly say no to pinch effect in an ionized gas, opposite to what it is observed. Also, it will predict classical electrodynamics according to the Lorentz law that a beam, a high energetic beam, will always diverge because the particles, the similar particles, will repel. And this is contrary to the observation that is observed that beams do converge. And they use this technique, it's called the self-focusing effect. So clearly this is another effect that throws relativity out of the window. The only thing is that the establishment keeps quiet. Now, the essential thing is that we never have attraction according to relativity theory between similar charges. We might have a zero force between two moving particles only in the case they reach the velocity of light, but then it is not an attraction. Now let's see the twin brother, which is the cardinal law, and which was equivalent in closed circuits. What will predict in this case? Now, the law that was suggested by Ampere was not including the electrostatic interaction, so somehow we have to upgrade this law. We have to do that. Whatever Lorentz did with the Biot-Savart law, he included the electrostatic field there. So we have somehow to include the electrostatic interaction. This is what I'm doing here. So I'm using the same identity Lorentz used to upgrade the Biot-Savart law there. It's a matter of history, just somebody had to do it. So it comes out like this, and this force now may be repulsive or may be attractive depending on the particular values of the velocities involved in vacuum. So it has a much different character now. And let's take a particular case, that is the charges are moving parallel side by side. The two velocities are equal to v. The charges are just the same. And the distance connecting them are just perpendicular, so they move just side by side. In this case, the cardinal law predicts the force between them will be this. And the Lorentz law predicts the force will be like that. We can see that this, the Lorentz force, will never change sign, because this factor always is positive. Always v over c remains smaller than unit. So this is always smaller than unit. So this is always a repulsive force. However, in the case of the Ampere law, this factor here does change sign if this here becomes over a certain value. Then it will change sign, and the force from repulsive will turn to attractive. And this is when the velocity is about 70% of the velocity of light. Repulsion changes into attraction. And this is not an extremely high velocity. It's a velocity that is about between two plates of 150 kilovolts. That will give you this acceleration equal to this acceleration enough to change the attraction, the repulsion into an attraction. Okay, so we have an essential thing which appears for the first time, and that might happen in vacuum when we have charges accelerating over a certain limit. In that case, repulsive forces will turn into attractive. That is, the pinch effect will appear, predicts the pinch effect very clearly. And that is in vacuum. If it is in plasma and the Coulomb force is partially annihilated because of the presence of opposite charges, the limit in velocity might be much, much lower. And if it is in conductors, might be in metallic conductors, this pinch force might be even very, very, very low. So actually the upper limit of 70% of the velocity of light concerns vacuum. And in every other case, the limit is much lower in practice. Now, we have to expect another effect, which is also noticed and recorded in St. Jackson's book of electrodynamics, but they keep quiet very much because there's no explanation. It's the kink effect, that the arc is in a state of instability, will break out, will break. Now, this breaking effect is very easily to discover. Is because current in the longitudinal direction always repels, and excuse me, I will not make an analysis, always a repulsion, whatever is the velocity. Now, this causes wires, when the current goes high, we have a very high current through a wire, the wire breaks into pieces. Peter Gragnon has done thousands of experiments in this way. Fuses break down before the wire has any sign of melting, provided you pass kiloampere pulse through it. It's a very well-established effect that even in the laboratory, that breaking effects will occur. If you take a small thin wire and you short circuit your mains, put it in a plastic bag with a heavy-duty wires, just put it in the mains, you are going to blow your fuses, but you are going to see the thin wire will break into very, very small fragments. It's a very easy experiment to do it at home. Or you will blow up your fuses, or if you take a capacitor bank, you can make a more sophisticated experiment without the expense of blowing the fuses. So, we expect another fact that arcs have an inherent instability, which is also known, and in plasma physics as well. Now let's consider in a very simple way what are the consequences of attraction, repulsion turning into attraction? Okay, suppose initially we have two charges traveling side by side, and they have surpassed the limit, and they are attracted according to the cardinal law of electrodynamics. In this case, the force between them is like a suppressed spring. So as they travel, they are repelled because of the electrostatic field, but the cardinal law will squeeze the electric field like a spring. We load the spring, okay? And they will approach each other. Sooner or later, we'll reach the anode. Sooner or later. It cannot travel at a high speed forever. Sooner or later, we'll reach a boundary. When they will reach a boundary, they will collide. What will happen? Obviously, they will lose the velocity. Now, these forces are velocity dependent. This is velocity dependent. If it is velocity dependent, the attraction will vanish suddenly, and only the Coulomb repulsion will remain. What will happen in that case? An explosion. Will happen an explosion. Probably what you see is that Tesla, at the top where the spark starts, there is a small explosion there. And another characteristic is that the spark will tend to move away at the longer distance as possible. And this is a common thing you see in all sparks. If you start a spark between 2 points, between two surfaces, the spark always will start between the closest distance, between 2 points of closest distance. Then the spark will move to remote points. And this is actually the sign we give to a spark that goes in a zigzag way, because it tries to elongate. It's like a compressed spring. It's a common characteristic of that. So there is no doubt that there is a repulsion in every arc. It tries to elongate. And sometimes it makes an arc. That's the name of the arc. It doesn't go the shortest distance, never. Always the shortest distance, which is or the easiest, the smallest resistance. The path with the smallest resistance or the path with the smallest distance will occur for the first stroke. Then it jumps into a very elongated path. Okay, so repulsion turns into attraction as its particles are accelerated between the cathode of an anode of an arc. Then the electric field is being compressed. And then, when they lose the velocity at the anode, there will be decompression, there will be an explosion. So some will reflect back, but some will go into the circuit and will give an excess energy into the circuit. So we expect two things out of this very simplistic description. Vibrations to occur due to the sparks itself, and independent of the characteristics of the circuit, but only dependent on the dynamics of the spark, the way I described it to you. And we also expect an excess energy because of the fact that repulsion turns into attraction and then again turns into repulsion. So let's consider a circuit, which is a very simple circuit, like the one is used in the primary of a Tesla coil. We have a capacitor bank, and we charge it, and we have a switch or a spark gap there. Whatever we have, we are going to have sparks there. We have a coil, and we have a detector coil connected to an oscilloscope. Theory predicts clearly that we are going to, if we close the circuit either through a spark or through a switch, theory, every book will tell you that you are going to have damping oscillations, provided the resistance is low, kept low. And the damping oscillations are given by this equation here. And this, the envelope there, is just an exponential function. And the frequency of this, or the angular frequency there, is the square root of 1 over CL. Depends, the frequency depends on the capacitance and inductance in the circuit, in the usual manner as everybody else knows, and the damping factor there depends on the resistance in the circuit and the inductance in the circuit. Okay, this is clear and straightforward if for such circuits. Actually, what we assume that happens in a spark, avalanche starts, and the resistance of the air breaks down, drops into almost practically zero. That's what theory says. Now, I will show you some oscillograms from various cases concerning this effect. All right, it's visible. This is a single shot oscillogram, 10 microseconds per division, the time base 10 microseconds per division, and more or less you see what you expect. Apart something, you see something, you see just the graph I showed you, a ringing frequency, this is called the ringing frequency, which is damped out. However, there are some spikes there, which you might call them artifacts. No way you are going to see these spikes if you are using an old, whatever, analog oscilloscope. The excursions here are too short to be visible on a screen. The only way to see those is using a very fast digital single shot oscilloscope, and everything, every point there is has the same luminosity, is independent of the duration of the trace. That's the only way to see that. You might think that this is an artifact. Let's take another one. Still the ringing frequency there, the artifacts still present. Another one. And another one. Now, there is something else that has drawn my attention since a long time ago. At the very beginning, there are also some spikes, which I used to see in an analog oscilloscope. The screen was flashing in a very strange way. Sometimes trying to get a picture, the film was spoiled, and we were thinking that was an artifact there. So now, having such an advanced oscilloscope, let's increase the time base going into nanoseconds. This was 10 microseconds. Let's go 100 times faster. Going 100 times faster, we discover here is the frequency recorded, and so there are many shots, and varies from 22 to 34. To 45 megacycles. Actually, in every book they will tell you concerning sparks that you can never go over megacycles. Now let's see another one, trying to see what's happening there. Now a similar one. We see a damping frequency there, and then another. The amplitude increases, drops again, increases, drops again, increases, until the whole effect is extinguished. Here again the same thing. And now the time base is much higher than the ringing frequency. It's much higher. So in principle we see that there are oscillations, and these oscillations actually change in the capacitor banks by a factor of 1,000, making the capacitor banks higher by a factor of 1,000, or changing the coil. They don't change. The ringing frequency does change, but these, sometimes people call them parasitic oscillations. They don't change, they persist the way they do. Now I'll show you from another setup, the same oscillogram. We have some, let's call them arc oscillations, and we see the ringing frequency, the ringing present there. And an excursion again, the the arc going up again. So let's look at another one. Again, the same thing. All the characteristics of this was actually a measurement of current by reversing the orientation of the detector coil. The oscillogram changes all polarities. So actually we can very well establish that the current in a circuit consists of a classical ringing frequency predicted by classical theory and a higher frequency which is not predicted by the classical theory, but it is predicted by the cardinal law of electrodynamics in a very simplistic way. This is another way, and still we have some excursions in the amplitude there, which we thought at the beginning was an artifact of our oscilloscope. Now let's see another setup using different spark. Now we can see the spark frequency dominating over the ringing frequency. The ringing frequency is just very limited there. Now let's see another one. This is important because you can see the ringing frequency there. Very clearly. You see the ringing and is modulated by the spark frequency. It's modulated. Now this is a very good situation because if the ringing frequency is present, we can calculate what is the energetic situation with the circuit according to the classical theory. So we have a situation that is a damping oscillation modulated by a higher frequency there. And in this case, the modulating frequency lasts much longer. The first ones lasted only about a quarter of a period, or a quarter of a half period there. This here lasts over several periods. And again, the same thing here is more clearly seen. Clearly we have a ringing frequency modulated by a higher frequency. And again, the same thing here. And again, I want to show you something else at the end. Let me show you everything. So it's pretty well established. And actually, before the event starts, there is no current going through the circuit. Everything starts all suddenly, very quickly. And you can see the rise time is very short there. Now, this group, we finished this group. Now I would like to show you something else. Now I would like to show you this. This is one that is dominated by the spark frequency, and the ringing frequency is almost absent there. You can see it's very weak. The amplitude of the ringing frequency is very, very low compared to the spark amplitude there. And this is very important from an energetic point of view. And here is almost missing, and so on. Here the ringing frequency probably does not exist, and we have a regeneration there, and almost no ringing frequency. Actually, we're expecting this one. It has no ringing frequency. It is there, but it should be very weak. And this is a very nice one. We can see that the oscillations have been damped completely, very little, and then we're regenerated up again. Okay, this is experimental fact now. And what is the conclusion? The conclusion is that in not every spark, but in certain sparks, others, the phenomenon is more enhanced, and in others it is less enhanced. However, two frequencies coexist there. Now let's make some analysis to see what we can say. Let's take the energy analysis of this kind of thing. Now the power dissipated in such a circuit will be I squared times R, the ohmic resistance plus the radiation resistance there. Now if the current is due to two currents, I1 and I2, which are sinusoidal with different frequencies, are an exponential decay in there with different exponential decays. So this integral will become like that. Squaring, we'll get the first integral plus the second integral plus twice the cross product of those two. And we can see the first integral is the power of the ringing frequency, and the second integral is the power of the second of the spark oscillation. And we have the double product. Now the double product here, the integral containing the double product, is practically zero for the following reason. If the second frequency, if the one frequency is much bigger than the other one, is zero, because we can see if we split the integral into sections, we can see that the high frequency reverses sign symmetrically with the other one, so it averages to zero, this one, though this factor remains constant here. The other one reverses plus and minus, so in the integration should be almost zero. Something practically residual will remain, but more or less for over a long time this will sum up to zero. So as a matter of fact, the signal consists of two energies: the energy of the ringing signal plus something which we cannot count, was not there, and we don't know what it is. Normally we discharge the circuit. The power we expect will be the power stored in the capacitor bank, and will be just that. Now we have an excess energy there, and this is excess energy is bigger. The bigger is the modulation energy. Actually, this is a modulation effect. Always if you have a frequency, if you want to modulate that, you have to add extra energy. So it is not surprising if the spark is modulating the ringing frequency, the spark is adding energy there very clearly. This I know since I was a radio amateurist. When I wanted to modulate my carriage, I had to add some extra energy there. So this is not surprising. It's very clear that the signal is modulated, so somebody somewhere has to add an extra energy. And this extra energy, the amplitude of this extra energy depends on the amplitude of the modulation versus the amplitude of the ringing frequency. And in this case, you can see that is about of the same order of magnitude. So that is, the energy of this oscillation is doubled here. It's about 200% in excess. In other cases, for example this one, where the ringing frequency is almost not existing, the excess energy is much higher than 200%. And in the first ones, like this one, the excess energy, though the amplitude is very high, but the duration is very short, the excess energy compared to the total energy released from the capacitor bank should not be expected to be very high. So this diagram explains the Russian experiment you mentioned, George, and as well explain my experiment, which I referred to in the previous lecture. So we have energy produced out of energy, and if we assume as an experimental fact that energy can be transformed into matter, we might expect that since all matter is electrical, in the Earth, in an accidental way, some excess energy will be produced and some excess matter will be produced, naturally. Because currents, there are everywhere currents, electrons circulate around the nucleus. So in practice, we have currents more or less in the same way that do exist in the sparks. So we do expect, if we have a rock like this one, somehow naturally to produce energy, also to produce matter. And this rock was taken from deep earth. I will show you later in the science if we go to time. I don't know, I run out of time. It shows that something is developing here, and this small one, something is developing on top of here. So we can call the new matter generated out of the old matter as the phenomenon of protolysis. We can call protolion just the generated matter, the child matter. Protolytic, just the adjective of this. Metrolysis, just the mother matter. And so on. Now let's go to do some calculations. Just a very simple model. Now let's take a statistical factor for energy generation in a bulk matter like this one. And this is estimated by trial and error and see where we get to. So my trial and error proved the best value to choose was 1 part 10 to the 8th parts in 1 year. That is, out of 10 to the 8th parts in 1 year, 1 part will be generated just spontaneously, and preferably will be of the same kind. Now let's take the mass. The present mass of the Earth is some 5.9 10 to 24. Age of the Earth is something 4.5 billion years. Mass of the Sun is 1.98 10 to the 30. And the metrolytic mass for the Earth and for the Sun, let's say it was 100 tons. What do I mean by that? That was in space, in vacuum, there were just a rock which was of the size of a big truck there. Now, and that rock will spontaneously generate more matter at the rate of 1 part 10 to 10 to the 8th per year. Then, then this model has to obey such an equation, that is, the rate of increase of mass will be proportional k times to the existing mass. And the solution of this equation is this one is an exponential equation. And this will lead us to the following results. The present day mass of the Earth, which will develop out of that rock, will be almost what we know. The present day of the mass of the Sun will be just what we know. The rate of the Earth's dimension, provided that the density keeps constant, because the mass increases, and we assume the density is kept constant approximately, and just make this assumption. The rate of increase of dimensions will increase about 2 centimeters per year. This is the rate that the continents go apart. It's about 2 centimeters per year. It's a well-known effect. Also, the same effect will occur in the height, in every dimension. That is, every 2 points the radius of the Earth will increase, and the meridian and the equator will increase by the same factor. Now, this explains something else, why the tectonic plates will move and cause earthquakes. Another fact we are going to have is that about 200 million years, the gravity on the Earth will be just the half that it is now, or in the next 200 million years, the gravity will double what it is now. That is, we are going to wait twice. We are waiting now. This probably explains why the huge dinosaurs and the huge birds that were all over the planet about 100,000 years ago and 200,000 years, million years, extinguished, because the gravity doubled and they were not able to fly, they were not able to walk. Okay, now let's go to another one, which seems too good to believe. Considering the heat energy as metrolytic energy in the Sun, which is 10 to the 48 ergs, that's the total energy, heat energy in the Sun, then out of this energy, according to the same equation, more energy will be generated with the same coefficient, and this generated energy, or power per time, the power, is just of the same order the radiation rate of the Sun. The radiation, it's a little higher, it's about a little higher, but it's about the same order. So the radiation of the Sun, the heat, the produced heat of the Sun, might be because of this effect, free energy. This is too good to be believed anyway. Now, I have a series of slides to show you that indeed the Earth increases. You will be surprised, but I have a proof of that. So can we go on to slides? And in the meantime, if I run out of time, because I have to show you a lot of slides about it, you are free to go, but I will keep showing slides now. Can I have the slide projector, please, on?
You know, what I was thinking, if we're sort of breaking at this point, I could make a short announcement. I'd just like to break in with a very quick announcement. There were a couple changes in our schedule. So before you guys go, we do have a speaker change tonight. Charles Wright will be in at 7 o'clock for Mark Seifert, because Mark Seifert has not been able to arrive yet. So just want you to know that. There's also 9 to 11 tonight, there is a wine and cheese social. The other thing is that it's been arranged so that the coil demo will start basically when our 8 o'clock speaker finishes, so that there won't be any conflict there. He'll just lead us all out there together, so that'll work out very well. And the final thing is that the tapes of these lectures are available about a half hour after they're finished, and they're $7.50 each. If you get all 22, it's only $110, so you get a $55 savings if you get the entire series. Okay, back to you. Thank you.
Is that a video or is that?
These are audio tapes.
Yeah.
Okay, I didn't finish with astronomical applications. I can show you in this manner how stars will develop, how stars will explode into supernova and nova, how galaxies will explode, and out of one galaxy, more galaxies will be produced, and this is the reason that matter is always observed to be in clusters, like clusters of galaxies, aggregations of stars making the galaxy, and then aggregation of planets around the star, and so on. Now, what I'm going to show you, you will be surprised, that is, I'm going to show you from my country, which we have high mountains though, and we have a lot of seismic activity, a lot of geological activity takes place there. What will you see? It's a country that you can see constructions, modern constructions 1,000 years old, 2,000 years old, 3,000 years old, and 4,000 years old. Now, what I'm going to show you, without exception, every construction that is 1,000 years old will be by a meter lower than the ground level. A construction that is 2,000 years old will be about 2 meters, at least 2 meters below the present ground level, and so on. The older is the construction, the lower will be than the present level. And this is without exception, you will see that. And this happens in plains, and this happens on tropicals. What we know that the archaeologists always do excavations, always they dig to find old constructions. It's a common thing, but nobody has paid special attention why they have to dig. They assume that because mountains come down, because of the rain, because of the wind, then more material is concentrated into plains, and that's why the old constructions are at a lower level. However, the same effect I will show you in a minute does happen on mountains. So at least mountains go up about the same rate. We have a water production, the sea level goes up. You will see that the sea level goes up, no doubt about that, because we have many archaeological sites that are presently covered by seawater. We have archaeological sites that are almost at the sea level, and they have a problem, draining problem. And you will see, and that proves that the rate of increase of the sea is higher than the rate of increase of land. No doubt that the rate of increase of the water has gone up, and the rate of increase of the land has gone up, both. Okay, can you turn it on, please? Now, the explanation I am putting forward here is that is protolytic matter, is matter spontaneously generated on the planet Earth. If you have a better explanation for this, what you are going to see, just you suggest it to me. Okay. Here. What? It's on, all right.
It's no light.
The cap put a cap on it.
All right. This is the gate of Andriano. It's a Roman construction. It's not so walled, and you see it's below the present level of the street. And actually, this is what they just try to keep it the same level, so I presume they have excavated around here. What's happening?
These Hawkins? What about meteor dust? Put that meter in front for you. Push the button. What about meteor dust? Where is it? Sit there.
Are we going the right way?
No, you're going the reverse way. No.
Is that the right way?
No, it's the reverse way. This is the end.
Forward.
No.
You're still going the wrong way.
No, you show everything the reverse way. It's not the way I want to show you.
It's Colorado.
Okay, which should be going this way?
Should be the 1, 2, 3, 4.
Okay.
Colorado.
No, not reverse, forward. That way.
There we go.
Okay, it's reversed. It seems even if you push the forward button, it goes in reverse. You can do it by holding it in and then turn. You hold it in. Now you turn. You hold it in, then you can turn it.
All right.
Hold it in.
Okay, this is another construction here. This is much older and is much lower. And this is, you can see staircase going up, but you have to go staircase down, so that this present street level is much higher. And this you can see, it's below the street level, about a meter or so. And this below the street level there. Same thing.
Is Greece?
Yes, it's Greece. It's below the street level. This was an old street, and that is the modern street. It's below the street level. Oh, let's go to that. This is about 10 meters below the present street level. And it all happens in all constructions. There is no exception. This is a church about 1,000 years old, and now this is below the street level. You can see the street level there. You can see there. And this is another church there. Same thing. Same thing here. Same thing to this church. This is all about 1,000 years old. The same thing to this church here. You can see there. You can see the level there, and the level on the left is about a meter or so. There's another church. This is below the present level of the street. This is another church. This is a little important because the level of that church. Wait a minute. Don't press. Who's pressing? It's automatically. Okay. This was another church. Now this is the yard of the church. I'm not pressing it. And on the right here there is another temple. But you will see to reach this temple you have to walk from the yard of the church, which is lower than the street level, by the same amount. And you can see that this is 4 meters, and the church is about 2 meters below. So in the same location, the older construction is lower, and the church was lower compared to the houses around it. Now this is another location. Now you can see some houses are below the ground level, the present ground level. And now you can see that the earth is getting fat here. You can see it very clearly. You can see it here too. And this is a marker that left from the archaeologists. That there was on the top was the ground level, and they have to go 4 meters down to get those buildings out. You can see this head here goes up. Now this is below the ground level. Same thing here, the same thing here, the same thing. Now this is important because this is a wall, and on the top of the wall we can see deposits which are not removed by the wind, or they are not removed by the rain. They're kept there. It's on a high point. This is almost a narrow wall there. Now this is a castle on the top of a mountain, and there are some ground going up. Okay, the same thing here. The same thing here. You can see the ground around the walls. Now this is a very important picture because you can see somehow the ground going up the rock, and at this point, oh sorry, I want that picture. And here there is a wall. This tends to cover the wall, so on the left hand side of the wall is completely covered by soil. However, the right hand side is empty, so you cannot suggest that this ground comes from the mountain up. It should come from the lower point. Now this is a very high mountain, it's Delphi. It's a rocky mountain, you can see the rocks there. The rocks around, very steep, almost vertical. Now we can have a look around it. It's vertical rocks. Going down at an angle of 60 degrees they go down. And let's go take a close inspection. This is an old fountain, about 3,000 years old, and you can see that the rock stays as it was when this was smoothed out. You can see that this was smoothed out, and you can see the rock stays almost as it was. So you don't expect much material to come down from these rocks. This is very clear. Now there is a staircase going down, which is as it was. It still comes down. And then we reach a plateau, and there is something on the left there. Yes, there is a construction below the ground level there. Now where this ground has come up, of course it doesn't have come up from the rocks. Now you can see it again. And now you can see the other side. There is something. Now they do excavations on the side which is about 40 degrees inclination. Yes, they do excavations. There is the grader. And let's take a closer look. Yes, they have left a marker there, which was the original. There is the marker. They have found the wall. There is the wall, and there is the marker. So the ground on the mountain has gone up very clearly here. Again, the same thing. That's the marker left, which covers the wall. Same thing. So more excavations on almost on the top of the mountain. Another marker left. And now you can see all the walls are being covered by soil. You can see here these walls, they're being covered. And here again, all these pictures are about the same. Okay, let's change this. Now we have another one. How this goes. Let's start. Oh no, the slide is in there.
Is this press and do it?
No, the slide is in there.
You gotta get it back to zero before you release, back it up one.
There is a slide stuck there. No, I need a pencil. Do we have another one? I don't think I will make it. How do we get this one?
It has to be on zero, first try before it comes up to zero. One more over. There's a slide step. This should be a very bright spot on the line. Well, let's check. Yeah. That's a fan up.
see on the left the wall, and it's been covered by some deposits. Well, where is your marker? Okay, the same thing is happening here. I'm going to go. Now you can see a wall there, and all this ground accumulated over the wall. This is about 3,000 years old. The same thing here over the walls is grounded, just below the stiff rock. The same, they support it there. The same thing here. Same thing. Well, everything is being covered, the plains and the mountains. So what do you have to assume about it? Now this is an old wall and another rock is being formed over it. That's very strange, I discovered it. You can see a man-made wall and a rock formed over it. Now this is on the beach. Now you will see that. Actually there are a lot of trees around there. I could not take a proper picture of it. Now you can see the beach, you can see their tents. You can see somebody there. Okay, there are ruins there. And this is almost at the sea level now. And they have a problem of draining. There is some water there. You can see the umbrellas there. There's the sea there. It's very near the sea. So this was not built at the sea level when it was first built. But obviously the water level has increased. Now this is from the Bronze Age. This is 4 meters below the street level. You can see the car there. And this is another case like the previous one, because the sea level is almost about at this level here. The sea is just 50 meters on the left. Again, it's from the Bronze Age. It's just below the ground level. And now we discover a construction that is left in the water. It's been flooded. There it is, been flooded all over the world. There's no doubt sea comes up. There are many sites, actually this was left out, and many others covered by the water. But this I was lucky to find it out covered. Now this is a crater near the sea, near Athens. And it's not a high mountain, it's only a rocky thing there. However, a lot of water comes out, which is radioactive, and has a lot of minerals, so people with various diseases go there. It's a tremendous amount of water coming out of it, which is not rainwater. It's a very dry place, never rains. And it's a common thing there. We have so much water coming out of the ground, which is mineral water. So water is clearly produced, and it's not rainwater. Now this is a typical island from the Aegean Sea, and you can see it looks like being flooded. You can see how the sea goes around, and actually this was a mountain. And what is left is a mountain. All the islands look like mountains being flooded by the sea. And actually we know that it was the Aegis was a land, and after a flood, the water came over. So no doubt that water level increases as always the ground increases, but the rate of seawater increase is higher than the ground increase. Everything looks like flooded. Now this is another strange thing. This is a baby mountain. This is a baby mountain, and that's how I call it, just like a born mountain. Now let's take a close look. If we look there, there is a mine, something there. We can see a strange thing. We can see two different materials, one on top of the other, very strange way. One placed on top of the other. Again, two completely different materials. Something, the second one has grown after the first one was grown up. Now let's look at that mine too. We have two layers there in that rock. The same thing here. The same thing here. Now there are a lot of mines, as in 3,000 years old mines. This is my car approaching there. And there is, you can enter that hole and walk for the whole of the day, or as long as your flashlight will last. And you can go 300 meters under the ground. Now you can find strange rocks there, all sorts of rocks, like that rock I have picked it up from there. Now this rock is something strange. You see one material superimposed by a different material there. This is a common thing. One material superimposed by something else. Like the second material have been developed after the first was developed. Now this, again, between one material there is another material there. Now something develops on top of that. It's very clearly, you can see spots there. And you can see that, I have a piece of that rock is there on the left, you can examine that. Something develops on that. Now you can see this is a big rock. Among the rocks, something is squeezed there. You can see there in the middle, and eventually breaks the rock. Something squeezed, crystals are squeezed between there. Something is being produced inside. That rock is that one I have there. Crystals are developing all around it, which looks like a coral there, or looks like a tree. All this underlie the same law that Paul Laviolette talked to you before, that energy and mass is being produced in the same way in the stars, in the same way in small planets. Well, I think this is the end of it.
What about meteor dust? What's dust from the meteor dust? They say, like, I forgot, a centimeter a year that the Earth is covered in.
Yes, but water is also produced there, and maybe it is so. I don't know, but rocks are being produced, and this seems to increase inside the mine, which is, there is no air current there. We were working the whole of the day to this rock here.
Why is
this?
Excuse me. Why isn't the ground underneath the ruins also rising? So it's all.
I should say the ground under the ruins also rises, and everything rises. But on top of that, there is something extra, and this causes earthquakes. Usually we have a lot of earthquakes there, and this phenomenon happens to Rome. If you see the Colosseum, the same effect. The same thing happens in Turkey, in Israel, and many places in South America. I know in Incas they do excavation. So every archaeology has to do excavation to reach an old construction. So no doubt, everywhere earth increases, would suggest that certain places it increases more, and certain other increases less, but more or less everywhere is doing that. It's a universal phenomenon.
Where did you, or how did you arrive at the 10 to the -8 constant?
Oh, by a try and error. This, when I used that figure, came all the rest of the figures right. This was the only.
Yeah, in the case of the sun, remember we talked about this, that you can say that the sun hasn't changed its luminosity by more than 1% in the last 3 billion years. Otherwise, the Earth would have completely glaciated, and we couldn't have had life. Which predicts that the mass couldn't have changed by more than 1/10%, which in 1 billion years, which would make it 10 to the -12 per year, rather than 10 to the -8, if the Earth was the same as the sun.
Well, I don't know. Many things have changed since. I mean, it's only a very simplistic way. I cannot answer a model. I cannot answer your question. I would suggest that the mass increase is not proportional to the first power, but also might increase, as you suggest, to another power. I don't have the overhead projector to show this slide. And if we assume that it is proportional, this is a very interesting thing. Because other factors interfere there. I mean, mass escapes from the sun. We have to change the flag. Mass escapes out. For example, I'm not afraid that we are going to run out of oxygen because a lot of the water is being produced, vaporizes, goes to the upper atmosphere, breaks into hydrogen and oxygen. Hydrogen is known to escape. So eventually water is produced and that ends up with oxygen. So no matter how much we are going to consume, we are not going to run out of oxygen as soon as electrolysis takes place on Earth.
So you're saying that atoms reproduce themselves according to...
You're saying that atoms reproduce themselves according
Yes,
to...
what it seems that actually we are running this experiment because the guy who was taking us down to that mines, he told us that these crystals just appeared. They were not 2 years ago there. So it seems that there are certain places with a fast rate of mass production there. So what we did, we took a ring, a golden ring, put it in a bottle, and we were even there. We are going to check it after two years what's going to happen. And I'm saying that because all the gold I have inspected in the museums, which is all there, it's like, looks like sandpaper. It's not smooth. There are small, it's rough. Something is being produced on the surface, even on gold. It's never smooth like this one.
So could you have some kind of vibration that would make gold grow faster than normal?
Actually, well, I'll tell you soon about it. As I said, we plant gold. But I believe that if I throw this stone in the outer space, this will become a star eventually. This explains why we have clusters and galaxies and all sorts of... now, if you take a different power for this equation, you end up with this solution, which actually for small e coincides with that solution anyhow. The important thing is that you might end to infinity. That is, when k times et equals to 1, that becomes 0 to high power. So that means if a star follows this equation, not that equation, will end up to an explosion, like a supernova or a nova. And that indicates that this exponential factor might have changed over the years. For a small period, you can approximate this with that. You can see that from these approximations there. All with this into a first approximation is linear. Even it is this or that. So into a first approximation, the power does not enter. But if you extrapolate that too far, the higher powers also matter there.
If the mass is increasing, and you call it like proteolysis or whatever it is?
Proteolysis, yes.
What is the what does that mass turn into in terms of elements? Then what are the elements that appear?
Okay, from the mines, because it was a puzzle for me. Why mines exist? What is a mine? First of all, it makes the earth non-uniform. Here is gold, there is carbon, there is water, there is something else, sulfur. We assume that the earth was molten as they claimed it was. Everything should be uniform. Where if meteoritic matter falls on the earth, it should be uniform. As the earth rotates, why the preference into one place we have this material, another place we have something else. I mean, why the preferences in certain areas? And that explains like a plant which reproduces in an area. So if you have this kind of material in there, then it produces, it multiplies and multiplies. That's why it causes mines. And then some another material tries to take over. There is a law of similarity that it's like a mother and a son. It reproduces like a perfect replica. Seems that there is some, I don't know how to explain that, but it seems that does happen.
Like divas?
Hmm?
Divas, nature spirits, supposedly.
Oh, I don't know that. I see what I say what I see.
Are there new elements that are created though, or will there be?
Well, I suppose the elements will obey the ordinary laws of physics, and we cannot have more than 100 elements at all. They are not stable. They are unstable. Now, there is evidence for that is that before the earthquake activity, the radonium has a lifetime, mean half-life of 2 or 4 days, I don't remember. Increases suddenly, is released. And this is very strange, how radonium could be released if its half-time life is only 2 days. It could not be stored, it would be somehow produced. And this is a marker for an coming earthquake. So that indicates that before the earthquake, a lot of proteolysis takes place. This is how I started looking. It was very strange when I heard. I was very much surprised when I first heard before an earthquake, radonium is all around. Because radonium only lasts 2 days. Can't hear you. Only 2 days.
What is it that
Radonium.
It's 2 or 4 days, I don't remember now.
What's the atomic weight? I mean, what's
Radon.
Radon?
Yes. It's one of the markers for a coming earthquake. And this is a very short-living element, which if you assume that the whole of the Earth was made of radon, then it will decay too quickly. It will not, you cannot store it unless you produce it there. So an earthquake associates somehow with protolysis. It's an effect that also these effects explain why the tectonic plates are moving. Just the prediction comes just the right figure, 2 centimeters per year, which that's what they say. Yes.
If the dinosaurs disappeared 200 million years ago because of the increase of mass,
Because of the increase of gravity, yes.
what will happen to the human beings?
The same thing. Unless we leave the planet, we are not going to be able to walk unless we find a way to overcome gravity. And the heat will increase because the internal heat of in the Earth is explained the same way. Every planet, as Paul explained, every planet has an internal heat. The bigger is the mass, the bigger is the heat until it becomes a star. It lights. So we shall expect that the internal heat of the Earth will increase gradually, and the whole planet will become hotter and hotter.
When you did those spark gaps, was that down above the 0.7 speed of light?
Yes. Actually, the kick effect, because I said it breaks, it helps to reach the front runners, to reach this much higher than this limit automatically. When you're using much lower, the instability in the arc. We have two forces, the longitudinal and the transverse. The transverse produce more energy, but the longitudinal accelerate farther the beam. So even if the limiting velocity is much lower, automatically that multiplies.
So those experiments were done
it was of that order. But according to what we are talking, we have to exceed it well. It was not exceeding that. It was close, but not exceeding. I'm sorry, I'm not going to give any technical details, but you have seen it was various gaps and various things there. Others, they produce more, the effect more enhanced. But all of them they do produce it. Sometimes more enhanced and sometimes it's less enhanced. Any more questions?
So are you trying to work on a free energy device yourself?
Pardon?
Are you trying to work on a free energy device that reduces?
Yes, I had a patent on that. Just when I have described it here some years ago.
You integrated one closed circuit and one open circuit.
Pardon?
What can you say about an open circuit and a closed circuit?
The open circuit does not obey the classical laws of electrodynamics, the open one. And an open one is one that is physically open, like an antenna, or one that is interacted with a gap.
Like a particle operating in a magnetic field. There's a closed circuit and an open circuit is a particle. It seems to me that must work right at accelerator.
No, that does, the source, okay, there's a detail here. If the source is a closed circuit,
That's what I mean.
yes.
Yes.
Yes, that does apply. Yes, the classical electronics do apply there.
Otherwise, accelerator.
They do apply, yes. I think we have been discussing this 2 years ago. They do apply, yes. It's the same predictions. It's the source, more accurate. I had no time to.
Integrate with one circuit.
Unless you use two open ones, or if the source circuit is closed, then everything is all right. If the test circuit is not is closed, but the source circuit is open, things are not, or they are in trouble. So the minimum condition is the source circuit to be closed. The minimum condition for the. Any more?
Let me ask a question of semantics. Do you mean protolysis or protogenesis?
Protolysis, from the word analysis, means first released. First released. Just the synthetic of, you say analysis, I say protolysis. Here is the vocabulary.
It might be electrolysis?
Yes.